So, hello everyone. Today we're going to discuss about the next smaller element question that too belongs to the stacks playlist. And for now, we've already studied about the next greater element, right? And I hope you've seen that video. If not, then also it works. And maybe we can go ahead with this question. But if you still find any doubts, you can use the comment section. And also you can just switch back to the previous video that goes by next greater element, right? So let's just get to this question. Now, in this question, you'd be given an array of integers named ARR, and your task is to find the next smaller element, NSE, for every element in that array. The next smaller element for an array is defined as the first element to the right that is smaller. If there is no smaller element to the right, then the NSE is -1. The next smaller element is -1. So, to go by the human method, no algorithms, nothing. It's just about what you see and what you can, interpret from that. What could be the answer array? You see 4, then you see 2. So you will say for 4, the next smallest element, this is the next smallest element array. For 4, the next smaller element is 2. For 8, the next smaller is 5. For 5, it's 2. For 2, it's -1. For 25, it's -1. Right? I hope you get that. With that, let's just take another example, the last one, 10, 9, 8, and 7. And then our answer, that is NSE array, next smaller element array. For 10, the next smallest is 9. For 9, the next smaller is 8. For 8, the next smallest is 7. For 7, the next smallest is -1. I hope you're able to get this. Now we'll come to the approaches of how can we solve this question. So if I go by approach 1, that is supposed to be the naive approach, right? As to how did we humanly manage to do this, given we have no constraint on space, we have no constraint on time, and that is how we're going to see. In the layman way, how can we do this question? So if I tell you, let's just stay at 4, okay? And take this array. This is my answer array. You may count this to be big O of n space complexity, and you may not, because this is your, this has been a lot of discussion among the interviewers, among the candidates, that should we take this as big O of n or should we not? Because this is an array that has to be returned. So some people count this in the space complexity and some do not. So if you're telling that you go by big O of n, or if you're telling that you go by big O of 1 space complexity, you have to be ultra clear in why do you choose it and why do you not choose it. So it's up to you. But you should be able to convince the interviewer, convince the person whosoever has asked you, because the interviewer knows in mind that, okay, if you're giving the big O of 1 answer to it, or if you're giving big O of n answer to it, you need to have a concrete proof to back it up, right? So given in that, you can go with big O of n or you can go with big O of 1. Depends on how convinced you are with what approach you want to go ahead with. Then you start, here is your I. You start your j from here, take it up to the end element. If you see an element that is smaller than array of I, you break and then you put that element here. So while your I is here, your j goes here and checks. Are you smaller than array I? 8 says no, then it goes to 5. Then it says, are you smaller than array of I? 5 says no, then it goes to 2 and checks. Are you smaller than array of I? It says yes, so it breaks. And then you get 2 here. Then your I moves next. J moves to I plus 1. So your J is I plus 1. Right? So with that, you complete this array and your space complexity is big O of n square. One loop that goes from 0 to n, or 0 to, if I have to be clear, it goes from 0 to n minus 1. Then you have a dependent loop that grows from j is I to n minus 1. J is I plus 1 to n minus 1. And here you do all the things and you break if your if condition holds true and rest, right? And if it does not hold true, maybe you can do a thing, just fill this array with -1 entries, right? Or else you can also put up a condition that if your for loop is done, but you could not find anything, that you can move that as -1. Before moving your I, if your for loop, if your inner for loop actually did not break up, then you can put that entry as -1. So whatever you're comfortable with, just go ahead with that. And the complexity stays big O of n square. Now we'll come to the approach that I want to discuss. That is your approach 2, that is using stacks. Now, to be honest, this approach will only come to your mind during the interview if you already know of this concept. Some concepts you cannot just think and just devise an algorithm. That also during the time of your interview, it is harder to do that phase, right? So you need to know it beforehand so that you can just confidently implement it at that moment. Because under the interview pressure, or maybe under the exams pressure, things do not go the way they are intended to go, right? So maybe you need to know this approach right before your interview, right? So let's just go ahead with it. Coming to the question, it's 485 to 25. 4, 8, 5, 2 and 25. Make sense? Now I would need a stack. Why and how, that you will understand as I go into the solution, right? And then you will understand why. So, okay. Now see, when I'm here, I don't know what all elements are here because I have not visited them. One way to visit them all is to use a for loop, that is a dependent for loop, that's then when your I is here, your j is here. This is your option 1, right? And option 2 is to traverse the array from here, right? Traverse from opposite direction. Do you get that? Because if you traverse from opposite direction, then when you come here, you already know what all elements were there, right? Are you getting that? Also, whenever I am here and I have to find the answer to this, I know the answer that belongs to here actually resides here. Could be any element that is after my given element, right? The index. If I have to find the answer to the ith index, the potential candidates are all the elements that start with I plus 1, right? Because I have to find the next greater element and not the previous ones, right? So if I traverse from opposite direction, I can be sure that when I reach here, I've already seen these elements. Does it make sense? Okay. So now we have 4, 8, 5, 2, and 25. What do? I start with here. 25. And then this is my answer array. Makes sense? Makes sense. This is my answer array. When I come on 25, right, I see that the stack is empty. And if my stack is empty, what do? If my stack is empty, I place -1 here. And I put the element, the array value at the index I, this is my I, in the stack. So the stack has 25. Now I go to 2. When I reach 2, I see, is the stack empty? The stack says no, I'm not empty. Then I start popping out the elements until I find an element at the top of the stack that is lesser than the value of array I. Now, while I'm popping from the stack, two cases can happen. Either the stack can become empty, or I can get an element at the top of the stack that is lesser than the value of array I. Make sense? Now, in this case, the stack gets empty. If the stack gets empty, I put -1 in the array and then push 2 here. Make sense? Now I come to 5. When I come on 5, I see the element at the top of the stack. First of all, stack is not empty, right? Then I see the element at the top of the stack. If the element at the top of the stack is lesser than the element array, the array I, then I take this value, top of the stack, and put it in my answer array and then push this into the stack. Make sense? I minus 8. Then I see the top of the stack. Are you lesser? It says, yes, I'm lesser than you, right? So I take the value and put it in my answer and also push 8 into the stack. Then I minus minus. I reach 4. Then I check at the top of the stack. 8. Are you lesser than me? 8 says no. Then I say you just pop off. Then I see 5. I say, are you lesser than me? It says no. Then I say just pop off. As I told before, two conditions can occur. One, stack is empty, right? Or stack dot top, it gets lesser than my array I. Now here what happens? Stack dot top got lesser than array I, so I push it here. Do you get that? And then I push 4 into the stack. So this is my answer. Now, all these values that I've populated in here as a different array, you can also move these values here. Now, that depends on your interviewer and also on your approach. You can give this as a second approach that maybe this is a controversial big O of n time complexity. And you can go a step forward by doing this. Does that make sense? Right? And what about the space complexity? We traverse the array once. And n is your number of elements in input array. Now let's just get to the coding part. So I guess this should be a pretty cakewalk for you if you've already gone through the next greater element code. Okay? If not, let's just go again through it. First of all, the return type, that is vector, right? Then next smaller element is the function name. What have you been given as the input? Vector int array. Make sense? Then what you have to return? Vector int resultant. Int n is your array dot size. Make sense? Okay. Now we have to traverse the array. Traverse the array, but from your opposite direction. Because you already know we have to find the next and we should have already visited it, right? So for int I is n minus 1, I greater than equal to 0, I minus minus. Now what can happen? While my stack is not empty. Or what? What else do I have to check? That my stacks, I wrote it before, right? The condition, I've written it already before. What? Stack stop. Now, why and? Because stack stop cannot come if stack is empty, right? You cannot check the second condition. This will throw an error if this is empty. Make sense? Okay, let's just clear all this mess here. So if my stack dot top, what happens to my stack dot top? I wrote it, I remember. Yeah. Stack dot top, if it gets lesser than your array I, then we have a problem. So till when we have to keep popping? Until it is greater than your, what is the input? Array, no? Yeah. So array I. If this is the case, you can keep on popping the elements. Make sense? Okay. Now this, you can get out of this only when either your stack gets to be empty, right? And if your stack gets to be empty, then what do? You make your resultant I as minus 1. Else, that means this condition, stack dot top, is now lesser than array I. Then your resultant I is equal to your stack dot top. I hope it makes sense. And in all these cases, you have to push array I into the stack. Right? And then you have to return your resultant. That makes sense. Now this, I'll make this color so that you know this is the end of the code. I hope you could understand it. You know why the time complexity, because we have this main loop, hence your time complexity, it comes out to be big O of n, right? And I think we're good, right? So the space complexity is big O of n for the stack. You can say big O of n for the output array, right? Big O of n. But this space complexity, you know, you can remove it, right? I told you that you can also make amendments to the input array. But to be honest, that is not advised. It is not advised that you make changes to the input array until and unless you've presented this approach and then you ask your interviewer or whosoever is concerned that would they like you to make changes to the input, given input, right? And with this, I guess you should be good. And you know what? If I tell you, the only difference between the next smaller element and the next greater element is this sign. If you put this sign the other way around, if you put this as lesser than, then this becomes the code for your NGE. And when you put it this way, it becomes the code for your NSE. So yeah, with this, I'll take your leave. If you have any doubts, any concerns going forward, any questions you want me to take up, just drop them in the comment section. With that, I shall take your leave. Thank you so much. Bye-bye.